Hello everyone, welcome to this video. Let us start with the solution of LTC AIIMS chemistry weekend test. Here is our question 1. The anomalous pair in Mendeleev's periodic table is tellurium and iodine because the atomic mass of tellurium is 128 and the atomic mass of iodine is 127, right? So instead of being arranged in the order of increasing atomic mass, it was the reverse, right? So this becomes an anomalous pair. Which of the following statements is not true about F block elements? These three statements are correct, but in case of cerium to lutetium, the atomic radius decreases because of the lanthanide contraction, right? Because of the poor shielding effect of 4f electrons, effective nuclear charge increases, and this is what we call lanthanide contraction, the decrease in the atomic radii from cerium to lutetium in 4f series elements. The element with Z is equal to 54, it belongs to 18 group definitely because Z is equal to 54 is xenon, right, which is a noble gas. Helium is an S block element. No, it is a noble gas. It is placed in group 18. The electronic configuration of helium is 1s2. Yes, this is correct because it has 2 electrons. So this is the correct answer. The correct trend of atomic radius decreases across the period. So lithium has the largest size, then beryllium, then boron, and then carbon. So this is the correct answer. Out of these elements, how many cannot have a covalency greater than 4? You see, boron and oxygen, these are second period elements. So they don't have low energy d orbitals. So they cannot expand their covalence beyond 4, right? They only have ns and 3 np orbitals, right? Whereas chlorine, sulfur, and silicon, they are third period elements. They do have vacant 3d orbitals. Their covalence can be greater than 4. So two elements cannot have covalency greater than 4. All right. All the following processes are endothermic except, so we have to talk about the exothermic process. So all these are endothermic processes. The removal of electron, addition of second electron is endothermic because of the electron-electron repulsions. And in this case, the addition of electron to a neutral atom in general, it is exothermic, right? So that is the correct answer. An element M shows a sudden jump in its fourth ionization potential. This means that the removal of fourth electron is very difficult. So obviously fourth electron cannot be a valence electron because valence electron can be removed relatively more easily as compared to the core electrons. So the element has 3 valence electrons, all right, and sulfate. Guys, the charge on sulfate is 2. So you cross multiply. So you will see that its formula will be M2SO4 thrice. Which of the following trend is correct for the size? Yes, anion is larger than the parent atom because of the electron repulsions. Z effective decreases, right? And cation is smaller than the parent atoms because of the increase in the effective nuclear charge. Beryllium oxide is amphoteric. You guys should know that. You guys should be aware about the oxides which are amphoteric in nature. SO3 is acidic, right? It is a non-metal oxide. NO is neutral. Again, neutral oxides are important, and MgO being a metal oxide, it is basic, right? So this is the correct answer. Molar solubility of silver chromate. Silver chromate, guys, it is Ag2CrO4. All right. So there are 2 cations, 1 anion. So the solubility product of the silver chromate salt can be expressed as 2 square, then 1 raised to the power 1, and then solubility raised to the power 2 plus 1. So which gives us 4s cube. Ammonium hydroxide shows common ion effect. See, for common ion effect, there should be a common ion. So hydroxide, ammonium, ammonium, these are common ions, but HCl doesn't have any common ion with NH4OH. So it becomes a correct answer because common ion effect will not operate here. Okay. Which one of the following salt undergoes both cationic and anionic hydrolysis? If the salt comes from weak base, it undergoes cationic hydrolysis, and if the salt comes from weak acid, then it undergoes anionic hydrolysis, right? So in this case, the acid is weak, acetic acid, and the base is weak, ammonia. So because both are weak, the conjugate parts will be strong and they both will undergo hydrolysis. The aqueous solution with least pH, this is easy. All these are salts, whereas HI is one of the strongest acids. It will have a very low pH value. Okay. K of acetic acid is 2 into 10 to the power minus 5. Buffer capacity of this is maximum. Always remember, guys, buffer capacity of an acid buffer is maximum if pH and pK both are equal. All right. So you can just find out the pK, which will come out to be 4.7, and that will be our pH. Okay. At 298 Kelvin, a mixture contains 100 ml of 0.01 molar ammonium hydroxide and 10 ml of 0.1 molar NH4Cl. So pH of the mixture is, so this is a basic buffer, all right, and Kb is Kb of NH4H is 10 to minus 5, so pKb will become 5. Is that clear? pKb will become 5. So you will have to find out the pOH. Okay, so pOH will be pKb. What is it equal to? pKb plus log for the conjugate acid divided by base, the concentration of base. All right, pKb, because Kb is 10 to minus 5, so pKb will be 5. So this is 5 plus logarithm. For ammonium hydroxide, it is 100 into 0.01. So this is 1 millimole. And for NH4Cl, that is conjugate acid of ammonium hydroxide, it is 10 into 0.1. So which is again 1. Log 1 is 0. So pOH is 5. And hence pH is 14 minus pOH, which is 14 minus 5, that is 9. So that is the correct answer. pH of 0.01 molar weak monoprotic acid. Okay, for weak monoprotic acid, H plus ion concentration is either it is equal to C alpha or it is equal to under root CK. So we'll use the latter formula, right? So it will be under root of concentration is 10 raised to minus 2 and the dissociation constant, it is 4 into 10 raised to minus 4. So this will be 4 into 10 to the minus 6, which when taken out of the square root, it will be 2 into 10 to the minus 3 molar. So you can find out the pH, it will come out to be 2.7 approximately, right? Clear, guys? Then next question, the strongest conjugate base will be the one which is weakest acid, right? So HCl and CH3COH and HCN, hydrocyanic acid, and HI. So guys, these are very strong acids, so the conjugate base will be very weak. As regards acetic acid and HCN, this is resonance stabilized, okay, but this is a carbon acid, so obviously it has to be the weakest, so definitely its conjugate base is strongest. So this is a correct answer. Equal volumes of two solutions of pH 9 and 12. See, both are alkaline solutions, so we'll have to do it through pOH. So for this, pOH will be 5 because temperature is 25 degrees Celsius and the sum of pH and pOH is 14, right? So pH 9 indicates pOH is 5, which in turn means hydroxide and concentration is 10 to minus 5 molar, okay? Likewise, for pH is equal to 12, pH is equal to 2 and hydroxide concentration is 10 to minus 2 molar. Now, because I'm mixing equal volumes, okay, so what will be the resultant hydroxide ion concentration? It will be 10 raised to minus 5 multiplied by V plus 10 raised to minus 2 multiplied by V divided by, because equal volumes are being mixed, so volume will double up, right? So this V will cancel out, and you see 10 raised to minus 5 is 1000 times smaller than 10 raised to minus 2. So we can simply ignore it, and what we will have here is 10 raised to minus 2 divided by 2. So this will be 5 into 10 raised to minus 3 molar. So you have hydroxide ion concentration. From here you find out pOH and then you subtract it from 14. So you will get the pH. Okay. So this will be a correct answer. NH3 plus HCl is a neutralization reaction according to Bronsted-Lewis theory, because ammonia accepts an electron pair. So it is a Bronsted base. Ammonia accepts a proton. So it is a Bronsted base, and HCl donates a proton. So it is a Bronsted acid. Okay. At 298 Kelvin, pH of 10 to minus 8 molar HCl. So if you find out it directly, this will be confusing because pH will come out to be 8, but this is an HCl solution. So yes, at such low concentrations of acid, we must consider the contribution of water, right? Water also dissociates to give 10 to minus 7 molar H plus ions at 298 Kelvin. So if you consider that also, the pH of an acidic solution will be little bit below 7, right? So this will be our answer, 6.956. Correct statement, okay? So this is the correct statement. NaCl can be precipitated from its saturated solution by passing HCl gas, because there the common ion effect will act, okay? The rest other three statements are incorrect. Which one of the following species cannot have a conjugate base? Okay, so this comes from H3PO3, which basically is a monobasic acid, right? So it dissociates into H plus and H2PO2 minus. We cannot remove any H plus ions from it now, okay? So this, it cannot have conjugate base, and thus it is a correct answer. Which of the carbon ion is most stable? Carbon ions have negative charge and alkyl groups are electron donating, which is not favorable. So lesser the number of alkyl groups, better it is. So methyl CH3 minus carbon ion is the most stable carbon ion, okay? Correct order of increasing stability of the given carbocations is, so you see halogens have dominating minus I effect. They sort of deactivate So it will be less stable, this will be less stable. Out of these two, A and B, methyl group is weakly donating, so it will be most stable here. So B is going to be the most stable, and out of NO2 and Cl, NO2 is a very powerful electron withdrawing group, so it will be least stable. So C, then D, then A, because there is no stabilization or destabilization, okay, as compared to the three groups, and so B will come at last. So this is a correct order. Which one of the following has least pK value? See guys, acidic strength is inversely proportional to pK. Now you should know that alcohols are weaker acids than water except methanol, right? So water is a stronger acid than all of them. It will have lower pK value than all alcohols except methanol. So water has the least pK value, okay? Most acidic substance, yes, because an acid leaves a conjugate base upon release of proton, which has negative charge, so electron withdrawing groups will stabilize it, okay? So out of NO2, CHO, CH3 and hydrogen, which is the most powerful electron withdrawing group? Of course, NO2. So this will be the most acidic substance here. K value is highest for, that means we are talking about the acidic strength. You see, acidic strength depends directly on K and inversely on pK, okay? So here bromine is far, here fluorine is far, here chlorine is near and fluorine is near. So out of chlorine and fluorine, fluorine is more powerful electron withdrawing because of higher electronegativity. So this conjugate base will be most stabilized, and hence it will have highest K or lowest pK, right? So this will be our answer. The species with maximum stability. Now we are talking about carbon ions. So we need electron withdrawing groups, and here you can see the hybridization. So this one is the most electronegative carbon, sp hybridized. So this will be most stable, right? Acetic acid is more acidic than phenol. Yes, because its resonance stabilization is important because a negative charge is on oxygen atoms. Whereas in case of phenol, except one structure, the other structures have negative charge on carbon. And we know that carbon is not a very electronegative atom. C minus is not particularly a contributing resonance structure. So let us see. Acetic acid is more acidic than phenol. Correct. Acetate ion has less number of canonical structures compared to phenoxide ion. Yes, acetate has only 2, and phenol you can draw a total of 5 structures for this. Okay? So both statements are correct, but that one is not an explanation. Tautomerism is exhibited when the compound has an alpha hydrogen, but this compound has all methyl groups here. So there is no alpha hydrogen. The other compounds do have, so tautomerism is not exhibited by this compound. Regarding tautomerism, incorrect statement is existed dynamic equilibrium with each other. It is correct. Tautomerism involves changing the position of electrons, but no change in the position of atoms. No, hydrogen atom oscillates, right? Between the two isomers. So tautomers are a special type of functional isomers. Yes, it is a type of functional isomerism, and they can be isolated at low temperatures. So this is the incorrect statement. Electromeric effect plus C, it is when the electron pair moves towards the attacking species, and which is electrophile. Yes, it is electrophile. And when the attacking species is a nucleophile, electron pair moves away from the attacking species, right? So this is a correct answer. Least acidic, you see ortho, para, nitrophenol, right? We know that resonance works at ortho and para positions. Picric acid has 3 nitro groups at the 2 ortho and 1 para position. So all these are going to be more acidic. Metanitrophenol, resonance does not work at meta position, only minus I effect will be there. So yes, metanitrophenol will be more acidic than phenol itself, but as compared to these 3 compounds, it will be less acidic. So this is our answer. Which of the following is not an acid derivative? Okay, so acid derivative is one in which this group can provide a good leaving group, right? But in case of aldehydes and ketones, this group is either an H hydrogen atom or an alkyl group, both of which cannot provide good leaving groups, so they are not acid derivatives. So this is the correct answer. Correct statements among the following are: non-metals will have covalent radius. Yes. Metals will have covalent crystal radius. Yes. Noble gases will have covalent radius. No. Okay. Except xenon, we do not know the stable compounds of other noble gases, so we cannot define covalent radius for them. So this is a correct answer. Incorrect trend among the following about first ionization potential. Yes. Out of beryllium and boron, as per the trend of ionization enthalpy, boron should have had higher ionization enthalpy. But because of the higher penetration effect of the 2s electron in beryllium, it has higher ionization enthalpy. So this is the incorrect trend. So that is the correct answer. The chalcogen with least magnitude of electron gain enthalpy is oxygen. Yes, in general, electron gain enthalpy becomes less negative or more positive down the group, but because of the electron-electron repulsions, oxygen has the least negative electron gain enthalpy in its group, and sulfur has the most negative. So this is our answer. The least polar bond, you'll have to see electronegativity. So the electronegativity difference is minimum between nitrogen and bromine. So this is our least polar covalent bond. Maximum valency of phosphorus with hydrogen is pH 3, is in pH 3, that is 3, and with respect to oxygen is in P2O5, right, or P4O10, so which is 5, the sum is 8. Correct decreasing trend of solubility of AgCl in UC, there are common ions, right, and here we don't have any common ion, and we know that common ion effect shifts the equilibrium in the backward direction and solubility decreases. So basically solubility is inversely proportional to the concentration of common ion. Okay. So in water there is no common ion, solubility will be maximum. So D will have the highest solubility, and then you see in which we have the least concentration of the common ion. Here we have 0.2 molar of chloride ion, right? 0.2 molar of chloride ion. Here we have 0.15 molar of chloride ion, and here we have 0.1 molar of silver ion. So yes, this is the least. So then A, then C, then B. Okay. So this is a correct answer. Solubility product of this hydroxide is given and solubility asked. So again, this is an application of common ion effect. Here what we do, guys, alright, so let us suppose the solubility is S, so metal ion concentration will be S, hydroxide will be 2S. But because we are talking about solubility in this solvent, which already has 0.01 molar hydroxide, so this will be added 0.01 molar hydroxide. Now let us write the expression for solubility product, which is the concentration of metal S and the concentration of hydroxide. It will be 2S plus 0.01 square, and which is given to be 1.8 into 10 to the minus 12. So again here approximation is applied that KSP is small, so solubility will be small, and because of the common ion effect it will decrease further, right? So as compared to 0.01 we can ignore this term 2S, right? It is always done like that. So solubility multiplied by 0.01 square, which is 10 to the minus 4, is equal to the KSP. You can work it out, no big deal. The answer will come out to be this one. Okay. pH of NH4CN is equal to the pH of 0.01 molar NH4CN. Yes, NH4CN comes from weak acid HCN and weak base ammonia. So the pH of a salt of weak acid and weak base is given by 7 plus half pKa minus pKb. So it is independent of the concentration. NaHCO3 is an acidic salt. Yes, because it can still give a proton like this, right? So both statements are correct. Which can form buffer? Strong acid is strong base? No way. Then weak base is 550 into 4, that is 200 millimole, and HCl is 100 millimole. Yes, there will be a partial neutralization of the base, so we will have a little amount of base left and some amount of its conjugate acid. So yes, that is the condition for a basic buffer. This will be buffer, right? In this case we will not have, because the acid is more, right? In this case also, strong acid, strong base, no possibility of a buffer. At a certain temperature, pH of 0.005 molar barium hydroxide is found to be 11.699. So pKw, guys, always remember, it may not be 14, but it will always be equal to pH plus pOH, right? Because temperature is not specified, I cannot assume it is 14. So pH is given, guys, 11.699. Let us find out pOH. Hydroxide ion concentration is how much? It is 0.005 multiplied by 2, because 2 hydroxide per molecule. So this is 0.01. So pOH is 2, right? So I will simply add pOH, which will give me 13.699. Okay. All the following carbocations are stabilized by resonance, except here we have a lone pair adjacent to the positive charge. Here we have a pi bond, right? Here we have a pi bond, but in this case, all the carbons are saturated. So it is hyperconjugation stabilized, but not resonance stabilized. pKb is highest. Just like acidic strength depends inversely on the pK, basic strength also depends inversely on the pKb value, right? So these are alkene amines. Aliphatic amines are more basic than aromatic amines, right? Because the lone pair on nitrogen is involved in delocalization with the benzene ring. So the electron density of the lone pair on nitrogen decreases and it becomes a weaker base as compared to the other three, right? So this is weakest base and it has highest pKb value. Incorrect statement, benzoic acid is less acidic than acetic acid. No, it is more acidic, because in benzoic acid, the carbon to which the carboxylic group is attached is sp2 hybridized, more electronegative, right? Diethylamine is more basic than ethylamine. This is correct. Secondary amines are more basic than primary, okay, amines. Formic acid is less acidic than acetic acid. Again, this is incorrect. Formic acid is more acidic than acetic acid because it does not have electron withdrawing group, electron donating group. Sorry, that is methyl in acetic acid, right? Benzylamine is less basic than aniline. No, actually, benzylamine is an aliphatic amine. It is not an aromatic amine. So it is CH2, NH2, right? So it is more basic. So the incorrect statements are A, C, and D. Okay, so that leaves only this one as the correct statement. Most acidic hydrogen, right? Here you'll have to see the electron withdrawing nature. So this is sp3 and this is sp2, right? And here we have an electron donating methyl group, but here we don't have any such group. So this is the most electronegative, sp. So that will be the most acidic hydrogen. Electrophile is electron loving species, in which case benzene ring is easily attacked by electrophile. Obviously there should be an electron donating group. Methyl is electron donating, but through hyperconjugation, which is weak. It is electron withdrawing group, right? Here we don't have any group, and yes, this is a powerful activating group, right? Because of the lone pair on oxygen atom. So this becomes our correct answer. Is that clear? Thank you, guys.